Hello, in this video we will solve an exercise about Newton's second law of motion. The figure below shows two masses, m1 equals 6 kilograms and m2 connected with an inextensible string. Inextensible string means that it doesn't extend or elongate, that passes over a frictionless massless pulley. Massless pulley means that the value of the magnitude of the tension before and after the pulley are the same. The mass m1 is pulled. This is m1. It is pulled from rest, from position A. From rest, it means that without initial velocity. So VA equal to 0. By a traction force F. This is the traction force of magnitude 80 newtons on a horizontal rough surface. Rough surface, it means that we have a force of friction on m1. The force of friction is always opposite to the direction of motion. This is the direction of motion to the right, then the force of friction must be to the left. Mass m2 slides up the smooth inclined plane that makes an angle 30 degrees with the horizontal. So as m1 goes to the right, m2 will go upward. However, m2 moves on a smooth surface. It means that there is no force of friction applied on m2. The magnitude of the tension T1 exerted by the string on mass m1 is 36 newtons. The mass m1 moves from position A to position B, covering a distance of 12 meters during 4 seconds. So m1 moves from A to B, and the distance AB is 12 meters during 4 seconds. Determine the acceleration A1 of the mass m1. Since m1 moves in a uniformly accelerated rectilinear motion, we could use the formula x equal half at squared plus v0t plus x0. X minus x0 represents the distance traveled by m1, which is AB, equal half at squared plus v0t. We already said that v0 equals 0 because m1 starts from rest. So the distance d equal half at squared. We will substitute with the value of d, which is 12, and the time, which is 4 seconds, and then we can find that the acceleration equal 1.5 meter per second squared. Calculate the speed of the mass m1 as it reaches point B. So we said that m1 starts at rest, so VA equal to 0, and we want to find VB. It moves from A to B with a uniformly accelerated rectilinear motion. We want to find its velocity at point B. So we apply the formula VB equal AT plus V0. Again, V0 is 0, so VB equal A1, we just found it, times the time it took the M1 to move from A to B, which is 4 seconds. So VB equal 6 meters per second. In this part, we have to apply Newton's second law to determine the expression of the frictional force F acting on M1 in terms of the mass M1, the traction force F, the acceleration of M1, and the tension T1. All of these are given. So we have to find the frictional force in terms of all of these values. So we apply Newton's second law on M1, which is sum of forces equal mass times acceleration. What are the forces acting on M1? We have the traction force, F. We also have the weight of M1 vertically downwards, the normal reaction of support vertically upwards. We have the tension force along the string and opposite to the direction of motion. And we have the frictional force, which is also opposite to the direction of motion because this is a rough surface. So put all of these forces here equal M1 times A1. This is a vector quantity. Now project along the x-axis because the force of friction that we want to find is along the x-axis. That's why we project along the x-axis. So let's see what is the projection of each of these forces along the x-axis. What about the traction force F? The projection along the x-axis is plus F because F has the same as the direction of motion. It is the force that's causing M1 to move. What's the projection of T along the x-axis? Since the tension T is opposite to the direction of motion, so we put minus T. The same for the force of friction because it's opposite to the direction of motion, so we put minus FF. Now the weight and the normal reaction of support, the projection along x-axis is 0 because both of them are along the y-axis, so they don't have x components. Equal m1 times a1. Note that we remove all the vector quantities after the projection. So the force of friction equal the traction force minus T minus m1 times a1. So we found the force of friction in terms of all of these four quantities as required. In this part, we have to deduce the magnitude of the frictional force F. We start from this equation here. So the force of friction equal the traction force minus T minus m1 times a1. We have the values of all of them. We just substitute them to get the value of the force of friction. So F equal 80 Newton. And the tension 36 Newtons. M1 is 6 kilograms and A1 is 1.5. So the force of friction is 35 Newtons. In this part, we want to represent on the diagram without a scale the forces acting on the mass M2. So now we are dealing with mass M2. What are the forces acting on M2? We have the tension along the string. We have the normal reaction of support, and we have the weight vertically downwards. As we said, M2, we don't have frictional force because M2 moves on a smooth surface. Now, in part 6, we have to apply Newton's second law on M2 to determine the value of its mass. So we apply Newton's second law of motion on M2. The sum of forces equal M2 times the acceleration. Note that the acceleration A2 is equal to the acceleration A1 because these all form one system. They move with the same acceleration. So we will put it A instead of A2. What are the forces? We said the tension, the weight W, the normal reaction equal M2 times A. We want to project along the x-axis. What's the projection of the tension along the x-axis? Note that in case of the inclined plane, we put the x-axis parallel to the inclined plane. And we put it the positive direction, the same as the direction of motion. Since M2 moves upwards, we will put the positive direction upwards. So what's the projection of the tension? It is plus T because they have the same direction. What about the weight W? We take perpendicular to the x-axis, so this is Wx. This is the projection of W along the x-axis. Note that Wx is opposite to the positive direction of motion. It is downwards, while the positive direction of motion is upwards. So we put minus Wx. What is the projection of the normal reaction of support along the x-axis? It is 0 because the normal reaction of support is along the y-axis. It doesn't have an x component. So these are equal to A times M2. Again, note that after projection, we remove the vector quantities. So T minus Wx plus 0 equal A M2. What is Wx? How can we find it? Okay, so this is Wx, the same as Wx here. This is the triangle that we have. And the angle here between the y-axis and W, this is the same as the angle of the inclined plane, which is 30 degrees. So sine 30 equal to the opposite, which is Wx, over the hypotenuse, which is facing the 90 degrees W. Sine 30 equal Wx over W. It means that Wx equal W sine 30, which is m times g times sine 30. So instead of Wx, we'll put mg sine 30 plus a m2. The tension, now we take the mass m2 common, g sine alpha plus a, and then we can find by substituting the values of the tension g sine alpha and the acceleration, we can find the value of the mass m2. In the last part, we want to determine the magnitude of the normal reaction force exerted by the inclined surface on the mass m2. So we want to find this force here, which is along the y-axis. Now, when we projected along the x-axis, the projection of the normal reaction along the x-axis was 0. So we cannot find this force by projecting along the x-axis. We must project along the y-axis. Apply Newton's first law of motion. Why do we apply Newton's first law of motion on the y-axis? Note that the mass m 2 doesn't move on the y-axis. It doesn't move upwards or downwards. It moves only along the x-axis. So it is at rest or at equilibrium along the y-axis. That's why we apply Newton's first law of motion. Sum of forces along the y-axis equal 0. They are balanced along the y-axis. What are the forces acting on the mass? Again, we have the tension, the weight, and the normal reaction. As we said, we will project along the y-axis. What's the projection of the tension along the y-axis? Since the tension is along the x-axis, it doesn't have a y component, so 0. What's the projection of the normal reaction? It is plus n, because the normal reaction is along the y-axis and it is they have the same direction, so plus n. What about w? The projection of w along the y-axis is minus w, because it is downwards while the positive y-axis is upwards. So minus w equal to 0. How can we find wy from this triangle here? Cosine 30 equal the adjacent over the hypotenuse, which is wy over w. It means that wy equal w cosine 30 equal m times g times cosine 30. We will substitute this value in this equation here. So n equal wy equal mg cosine 30. Substituting the value of the mass, the gravity, and cosine alpha, we can find the value of the normal reaction of support.